Hello, welcome back to AE 2220 Dynamics. In this video, we're going to just go through an introduction to what dynamics is and some of the things we'll be doing in the class. So first, everyone who is taking this class has taken statics previously, and statics is going to be the study of the mechanics of bodies of rest. So the study of the mechanics of bodies at rest, meaning that there's no motion occurring. Being at rest means that the body is not moving. In this case, Newton's second law was the sum of all of the forces. Those must be equal to 0, or the sum of all of the moments must be equal to 0 as well, because the right-hand side of these equations are where the motion occurs. In contrast, dynamics is the study of the mechanics of bodies in motion. So it's the study of the mechanics of bodies in motion. So rather than being at rest, now we're going to deal with how the thing's moving, and we're going to want to understand that motion as well. So in this case, Newton's second law is going to be that the sum of the forces will be equal to the mass times the acceleration, and that's the acceleration vector. Or for rotation, we'll be looking at the sum of the moments, and we'll just leave it as the angular momentum h for right now. We'll come and talk about what that is as we go through this class. In this class, we're going to spend a lot of time on this right-hand side. So these two terms, we're going to spend a lot of time here. We will spend, let's just say, a lot of time here, or on this part. So you have previously dealt with the force side of this, or the moment side of this equation. You did that in statics, and as a result, you have some expertise, some prior knowledge of that, but you haven't dealt with the right-hand side, and that's why we're going to end up spending a lot of time with that. And really, once we start going into it, start applying these techniques through like Newton's second law or energy work, that's where you'll really start to master that right-hand side. So dynamics is split into two areas. The first is kinematics, and this is the study of the motion of geometry. So we'll just write the study. In fact, it would say the study of the geometry of motion. That's what it should say. In that case, this entirely deals with that right-hand side of that second equation. And here we do not deal with any forces. It does not deal, or does not consider, let's say does not consider forces. So kinematics is purely on the geometry of the motion and is not concerned with any of the forces acting on a body. And then kinetics is then the study of the relation between the forces, the mass, and the motion of the body. Study of the relation between forces, mass, and motion of a body. And we need kinematics to study kinetics. So you cannot study the kinematics. You cannot study kinetics, without kinematics. We're going to leverage an algorithm, or just a problem-solving approach. algorithm is just shorter to say. So we're going to leverage an algorithm to solve problems. You're going to be very tempted to skip steps in this, and such as rushing ahead to draw free body diagrams. But you really need to slow down and trust this algorithm. The algorithm is split into two parts. The first deals with kinematics, and the second deals with the kinetics of the system. So when we're dealing with kinematics, we're going to start off by defining a coordinate system. And to do that, we're going to start by choosing an origin. First step, we'll choose an origin. We'll then define perpendicular directions, vector directions. And we'll start off with like Cartesian coordinates in this class, and then we'll go on to other types of coordinates, and we'll quickly diverge away from just Cartesian. And then we're going to determine, third, we'll determine the direction of positive rotation using the right-hand rule. So we're going to determine the direction of positive rotation and we're going to be using our right-hand rule for this. The second step is going to focus on position vectors, and we will go through and discuss what all of these are in detail as we go through the class. But we're going to start by defining a position vector. To do this, we will draw a position vector from the origin. We're going to draw a position vector from the origin to each body. That'll be our first step. And we may need to add dimensions to a particular system in order to be able to define what this is. And then our second step, we're going to write out each vector in our chosen or your chosen coordinate system. This is the part where you might need to add additional dimensions in order to be able to write out that position vector. And then third, you're going to compute velocity. And it says position vectors here. This should say acceleration. You're going to compute acceleration vectors for each object. And then I want to say here that steps 1 through 3 will stay the same for every problem we deal with. They will always be the same. Sometimes we won't need to compute a velocity vector, and we'll just need to compute we won't need to compute an acceleration vector, and we'll just stop at the velocity. But all of the other steps will be the same in general throughout this. Like I said, you're going to feel very tempted to jump ahead and skip, but always do the kinematics first. Deal with the kinematics and then apply the rest of the algorithm for kinetics. So everything stays the same for kinematics. When we get to kinetics, that's going to change based on what we're trying to do. And for different concepts, we're going to do different things, or different problems, different concepts from kinetics, we'll do different things. I'm just going to list an example here for Newton's second law. When we're trying to derive an equation of motion, let's say. First thing we're going to do at this point, we're going to draw a free body diagram for every body. Now you might need to do something like decomposing forces here, but free body diagram, and then we go from there. Then you're going to apply Newton's second law. Or Euler's laws, depending on what we're doing. we're going to say second law to each body. And then we're going to simplify and put it into a standard form. Okay, I don't expect you to memorize this algorithm at this point. We're gonna use this approach throughout the class, and we're gonna solve all of the example problems using this technique, and all of the worksheets will leverage this technique as well. And the real power of this technique is it allows you to determine the right-hand side of the equation first before dealing with the forces or the moments acting on the system. Thank you very much for listening.